In this video, I'm going to show you how I use Blender Precision Modeling to deal with a small little problem of mine. This small problem is basically my 3D printer doesn't fit on my desk. As you can see, it's just about to fall off, and this is how I've had it for almost a whole year, so I need to sort this out. Not only that, but right this minute, even at that extreme edge, you can see that I'm really putting a lot of tension on the power cable to my build plate. So I've got to really sort this out. So the first thing is first, let's get some dimensions. I want to pull my 3D printer forward and get this much space for the back of it, and my desk itself is this thick. Now lastly, we need to also know what the diameter of the feet are, so with those all grabbed, let's go over into Blender and model this out. Now if you want to see the first time of me going ahead and designing this and talking out loud everything that I'm thinking, there's a full-length video of that that's linked down in the description. However, this video is very much me just using the sort of technical drawing that I've already created of this to go ahead and show you Blender Precision Modeling in action. So let's go ahead and model this up. So now that you know the problem that I'm trying to solve, I'm going to go ahead and model up my solution. Now, of course, the technical drawing is down in the description, and I'm going to be following the technical drawing for this exact video. But if you want to see the first time that I went into it and how I do the sort of the idea generation of this, I have the entire full-length video down in the description for you to see what it's like for me when I'm designing for 3D printing right at the beginning. Anyway, so let's get straight into it. Of course, remember that if you don't know Blender and you don't have the add-ons that I'm working with, it's all linked down in the description. So make sure you go ahead and download the technical drawing first, and let's get on with this. So I'm going to go ahead and start this by creating a cube. I'm going to create this cube the thickness of the desk. So I'm going to go here, and it looks like from the technical drawing it's 25.3 millimeters. Okay, there we go. We've got something closely resembling there. I'm going to take this into edit mode. I'm going to select these three faces here, do a Shift D, right click, and then go back out. Oops, I forgot to go P and part selection. There we go. So now I can delete that cube and I have this weird shape here. Now there is one thing that we've got to make sure that we do right now, which is we have to also change the thickness of this right this minute. So let's change this thickness to 30 millimeters. And now that we've done this, we've got to make sure that our scale is set back to 1. So let's apply our scale. Okay, now with that done, let's take this into edit mode. Let's select this top face. Let's extrude this out by 5 millimeters. That's what it looks like. And down here, we're going to extrude this by 5 millimeters as well. And then I'm going to grab these three faces here. I'm going to go ahead, extrude these out by the full length here. Looks like 81.31. And then I'm going to go ahead and move these faces here using the scale of CAD transforms. So scale, move from here to there. And what I'm looking for here, the total distance I'm wanting is 60 millimeters. So 60 mm. And there we have it. Now you can see right this minute, our geometry is open. So let's close this up. So edge selection, selecting these edge. F, we can then just, undo that, select this one, just hold F and F once again, and that will be the F2 add-on in action. Right, so with that now in place, I'm going to go ahead and grab this edge loop along here. I'm also going to grab this edge loop here, because I don't think I'm going to need them for the rest of this project. So I'm going to go here with a dissolve of the edges. Fantastic. Now I'm going to grab this edge here. I'm going to do another scale positioning. So scale from this vertex to that vertex, and I'm scaling that up. I want this distance here from what I'm seeing in the drawing to be 7 millimeters. All right, so now that's 7 millimeters. I think a good time now would be to do that cut through hole. So I have a feeling the way that I did this while I was modeling it is that I did an offset, but we can't do that anymore. So let's go ahead, let's create a plane. I'm going to create this plane by the longest digit of this by 48.72. Great, so we have that there. I'm going to now just move this out on the X so that I have this nice and visible to me. I'm now going to go ahead and play around with the other one, with this one here, and I'm going to make this 18.1. All of this is in the technical drawing. So I'm going to apply that scale, take this into edit mode, go vertex selection, make sure I've got vertex snapping here, and I'm just going to go ahead, G to that vertex there, select everything, merge by distance. Great. So I've got this here, which is going to be basically my cutting object. So let's go ahead and let's rotate this in the right way. So rotate this on the Y by 90 degrees. Now I'm going to use a little bit of CAD transforms to put this in the right position. So G from here to that point there. And then let's go G on the Y. So that distance here is 5 in the other direction. And then we're going to go G, Z, and this full distance is 10 from what I can see. So let's go 5 down once again. Then I'm going to take this into edit mode. I'm going to extrude this out by some 50 odd. Now, I like to do it that way by putting in the number, because remember that if you were to just go ahead, extrude and pull it that way, you have just gone ahead and flipped your normal. So nothing wrong with that. Just make sure you select everything and go Shift N, and then that way you've gone ahead and recalculated your normal so that it's all blue. Anyway, with that now said, once again, let's take that out. Now I'm going to go select this, select that, and I'm just going to do an entire Boolean cut of that. You could have done a brush Boolean if you wanted to, but I wanted to do an auto Boolean. So that's that hole in place. Let's do the other hole as well. So I'm going to do the placement of this foot hole. So I'm going to go ahead. Let's put in a cylinder. I'm going to times this by 4. The radius that I'm looking for here is 11, and I'm going to go with a depth of 6, considering that the height of it, the depth of the hole is 5. So as you can tell, that this depth is the same depth as this, so it's the same height as the table. Okay, so let's bring this up now. So G, Z, up, and now we've got to be a little bit accurate here, as we need to find the vertex that is perfectly there. That's exactly what I'm looking for, that one there. Select everything here. Now I'm going to use some CAD transforms moving. So G from this one here to the edge center of that point there. Now I don't know the distance from over here, but I do know the distance from over there. So I've got to once again find the right vertex that I'm wanting to move from. So over on this end, on that bottom side there, select everything else. I'm going to go G from U, going to move along on the Y till we snap along to that point there. Then I'm going to go G once again from that vertex. Where are you? There you are. That vertex on the Y, and we're moving along here. How much are we moving? It says 57.81, so 57.81, and that's it there. Okay, now I'm just going to go with my normal movement, G, Z, 5 in the minus direction, and that should be now in place. Yes, I think that is in place. So because I don't think there's going to be any other edits from this point, I'm just going to go ahead and cut that away with a lovely Boolean. All right, now let's go ahead and put in these screw holes. But as you can see, do we need the bevels or chamfers for the screw hole placement? No, we don't. So I'm going to just create this cutting object. So I'm going to go here, let's create a cylinder. And the radius of this is going to be 3.75. That is because it is half of the number there. So with that now there, that should be right? Radius 3.75. Is that right? I don't know. Wait, no, I'm being silly. This should be 4. No, this should be 2 because this is the through hole. There we go. The through hole, and then the top bit is going to be 3.75. So we've got that through hole. I'm going to make the depth of this. Actually, leave it at 6. It doesn't really matter. I'm going to take this into edit mode now. I'm going to do a face selection of this top one and extrude this face up by 1.75. Now I'm going to use a CAD transform scaling. So turn on CAD transforms. I'm going to scale from the face center to a vertex over here. I need to make sure that that's a vertex. There we go, vertex. And of course, we need to do another dimensional scaling. So let's press tab. That gives us 2-dimensional scaling. And this is the one that needs to be 3.75. So 3.75 millimeters. Hit enter, and there we have it. Now, just for the sake of placement, and so that I know exactly where everything is, I'm going to extrude this up 1 millimeter. There's no other reason apart from knowing that that is 1 millimeter, so then I can move it later on, because I'm going to do a whole bunch of snapping now. So take that out, double check, scale's looking good, that's looking very nice, perfect. So let's go ahead and use some CAD transforms. So CAD transforms, G, I'm going to go from the face center here to that vertex over there, and the reason why is I'm going to go another Shift D, right click G from that face or vertex, because they're both exactly on the same spot, go like that. And I'm going to do another one, Shift D right here. I'm going to go here with a W, G on the X, moving U 15, and a minus for later. Actually, instead of doing that for later, we might as well just do it now. No, it's got to be for later because we're using the reference of the center of these for later. Okay, so let's start with these two. We can go G, Y, bring them down 13.15 in the other direction. Fantastic. Then we'll do each one. So G, X, we're moving U in 6.69 and U as well. GX minus 6.69. Yep. And now we've got to move U with CAD transforms from your face center on the Y to the same face center here. So then we can do a normal movement if we want, doing a GY, bringing you down by 32.59 in the minus direction, like that. Now we will select all of U3, and this is the reason why I did that 1 millimeter, so I can go GZ, oops, Z1. So now I know they're all 1 millimeter up. I'm going to join these all so that they're all one object, and the reason why is because I'm about to do a Boolean cut. So make sure that those are looking good, going through. Yep. Here, Control Shift minus, and there is our lovely screw holes. All right, now the last step is chamfering, filleting, and all that lovely stuff. So let's go ahead and start doing that. We're going to take this, make sure that it's on the 1 scale, take this into edit mode. I'm going to select everything before I do this, merge by distance, see if there was any vertices to get rid of. So sometimes Booleans do that, but nope, it looks like it's all worked out perfectly. So I'm going to go ahead, we're going to select this edge loop around here, I think, first. So let's select that there, Shift B, yep, can't do it like that. Let's go Shift B, come on, there we go. And I'm going to change this here by 0.97. Yep, that's exactly what the drawing tells me. And then we're going to go over to our edge selection, select these two, and let's give these, what is it, 4.4. Yeah, 4.4. There we go. And then we're going to select this edge loop around here. The same over on this side here. And let's give that one a nice little chamfer of, what's the chamfer? 2.5. Okay, 2.5 chamfer. And now we've got over on this side over here, we have these. So we'll select all of those right there. Do a nice little bevel, chamfer that. And what are we chamfering that? We're chamfering that 7. There we have it. So we give that a little look around, see how that's coming out. That looks like it is very clean, very sorted out. Let's select everything, merge by distance, everything is looking perfect. Let's do a quick 3D print check. Everything's looking good. Oh, we've got a couple of intersecting faces. Let's see where those are. Intersecting faces, where are you? So I've selected them. They're over here somewhere. Oh, they're right down here. I do not understand why you are intersecting faces, though. Let's see. If I go ahead, delete this face, there's no intersections going on there. So in reality, it's complaining about something that's got nothing to do. The non-flat face is just going on with this edge going to here. That's why. Oh, and that's why it's doing intersecting faces, because those are intersecting into those. We could actually just go ahead and clean that up, just for the sake of good practice, you know. So let's go here, GG. We should, oh, I need to make sure that we're in normal movement, GG, then we can move that to there. Then we can grab this one, GG, remember that moves it along the vertex. We have vertex snapping, so I'm just basically snapping this all the way across to that point there. Let's check on the rest of the model then. Select everything, pull out. Let's take a look closely over here somewhere, see if there's any problems there. That looks like it's doing all right. So let's just select everything, merge by distance. That should remove two vertices. Do another check, and you can see that that removed the intersecting faces and the other face problem. And it was all because of just that little thing. There was nothing actually wrong with it. Anyway, so that there should be perfect for 3D printing. Of course, we're not going to print it in this orientation. We're going to print it in a different orientation. So let's go ahead and export this. Remember, you can always go ahead and export things right here. Or if you want, you can go over and be old school like me, File, Export, STL, and I'll see you over in Prusa Slicer. Here we are now in Prusa Slicer, and everything seems to be coming out perfectly. So I'm going to go ahead and orientate this down like this, because that's the direction that it's going to be printed in. And let's just go and slice this, see how that's coming out. So this is coming out perfectly from what I can see. Now, this is definitely not enough infill for what I'm going to do for my own work. So what I'm going to actually do is I'm going to go to my printer settings, go over here, and I'm going to put the parameters here to a massive 8 perimeter walls. And this here means that I definitely know that this is going to be one hell of a strong print, as you can see. And that's basically it. So let's get that printed, installed, and then you can see the final result. And with that final little montage at the end, you can see that it's now in place and printing perfectly with no wobble whatsoever. I really did think that I would have to do more iterations of the design to get a design that's going to be strong enough not to have any wobble, but I got it first time. I probably over-engineered it, probably made it way too thick, but that's fine with me. As long as it works, that's it. A huge thank you to my patrons. You guys are absolutely awesome, and it's the reason why I'm able to make these videos completely free to offer as much precision modeling as possible for everyone. And if you're enjoying what I'm making here and you think I'm worthy of your support, I would love to see you there too. Don't forget that we have a Discord, and that's linked down in the description. Thank you for watching, keep making, and let the quest continue.